All right.
So yeah, good afternoon, good morning, and good evening, everyone, wherever you are. So this is Steptostem Episodes, and today we have Sanjit with us, and Sanjit is very excellent, innovator, or you can say software engineer, and by design he just loves to play with VR and AR. So today we have him, and he will discuss about the technology and how it can be utilized in today's generations and today's how we can use it to build a sophisticated system to understand the reality and robotics and everything. So yeah, Sanjit, you can present.
All right. So today I'll be giving you the talk of the future of VR, AR, and robotics. A lot of very, very cool applications. All right. So first, before I get into my talk, this is a little about me. So I'm Sanjit. I'm a student, a big fan of hackathons. I'm a big hacker, project lead at NASA Suits, space coach at AFWER, and an X-Force Fellow at the National Security Innovation Network, or NSIN for short term. And before all this, I was also the co-founder and former vice president of XBoost, where we were a biotechnology-focused startup focusing on developing next generation of exoskeleton devices and combining a VR, AR gamified environment for virtual rehabilitation therapy for stroke patients. But due to COVID, we failed to lack funds, so the startup had to discontinue. But there's always other good excitement going on. So a lot of stuff I focus on, as Sumit might have mentioned some of them, building the future of AR and VR, along with robotics, brain-computer interfaces, virtual worlds, AI, humanoid robots, and more cutting-edge technologies. So for any of you that are interested, you can connect with me here on LinkedIn or follow me on Twitter or both. I'm always happy to mentor students into the field and, connect and meet new people. All right, now let's actually get into the VR, AR aspects. Excited to expose you all. So let's start with the question. Well, what is virtual and augmented reality? So let's break down the concept. Virtual reality is more or less a 3D generated virtual environment in which users can interact as if they were already in that virtual world. So basically, they put on a headset and their mind and brain is basically tricked to believing that they're actually in the virtual world, like they're actually there. They're around a simulation to gain immersive experience of their surrounding of a whole 3D generated environment. Pretty cool stuff. Augmented reality is more like a 3D generated computer environment projected from the virtual world onto the real world as overlay or as holograms, you can say. So you can kind of look at, like, if you see the picture to the right underneath, augmented reality is more or less kind of like Iron Man, which is a big future we are headed into. So augmented reality is basically I bring virtual images onto the real world. Of course, we don't have the technology to make realistic holograms just like Iron Man just yet. That's why we have headsets, which I'll be getting into more detail to my next slide or a couple slides later. But first, before I get into more about the headsets, let's talk about how did these fields start. So actually, virtual augmented reality has been around between the 1950s to 1960s. Actually, this field actually is more newer today to the market, as in like it's more people are starting to get aware about it, but it's been around for a pretty good amount of time. So it started from these four pioneers. So Dr. Ivan Sutherland, who's heavily regarded as the father of computer graphics, he invented his 3D graphical interactive software known as Sketchpad. But the thing about it was he wanted to also explore the immersiveness and see how it'd like to be in a graphical immersive environment. So that's where he invented the first headset known as the Sword of Damocles. The Sword of Damocles was the very first virtual reality headset, except while it was interactive, immersive, it wasn't as advanced and mature, of course, as the VR headsets we have now. But the Sword of Damocles was a great start. Morton Hellig, he was actually the one who discovered how to integrate VR for stuff like filmmaking applications. So he discovered how VR can be used for filmmaking. And all the way to the right, this one's actually personally my favorite. On the top, Dr. Tom Furness. He's been in the game for about 55 years. He's regarded as the grandfather of virtual reality. His work started at the Wright-Patterson Armstrong Air Force Research Lab. That's where he actually first got exposed to cockpit systems for helmets for pilots. So what he decided was how to invent visual display systems for cockpit controllers through helmets, so the astronauts, the pilot who's piloting the aircraft is able to see where they're flying into the air, where they're going, and be able to do everything all at once, because that's super important cockpit controllers. So visual display systems actually is what led to virtual augmented reality and helped more further the field. So Tom Furness, like I said, he's been in the game for a very long time, and now he's a professor at the University of Washington, still doing what he's doing in virtual augmented reality. Guy's a big genius. Underneath is Dr. Greg Berdea. He's a professor at Rutgers University. His original work started with haptic devices and robotic rehabilitation assisted devices. So he combined these applications with Dr. Tom Furness. So Dr. Greg Berdea, as mentioned, he's a professor at Rutgers University. His work started with robotics, rehabilitation assisted devices, and haptic technology, where he combined it together in virtual reality, which led to the field known as virtual rehabilitation therapy. It's basically VR and AR gamification therapy for physical therapy, you can say, for neurological conditions. It's basically a way you can say you're gamifying therapy, which I'll be getting more into details later as I get into the applications about all this stuff. All right, so now types of VR, AR headsets. So I'm going to talk about each and every one of them in as much detail as possible. So HoloLens, I'm sure we're all familiar with HoloLens. It's a headset developed by Microsoft. So HoloLens is actually an augmented reality headset. So as mentioned, augmented reality is basically projecting virtual images from the virtual world onto the real world as holograms you can interact with. So HoloLens is one of those really, really powerful immersive headset with a very good depth sensing camera. It's able to project realistic images, and a lot of those are just based off gesture clicks, so just tapping with your fingers. Magic Leap is another great augmented reality headset, also very immersive, powerful field of view and depth sensing. The interaction with that controller, the joystick controller, you see here. So Magic Leap basically uses a haptic controller, you can say, except, well, wouldn't say it's like advanced haptics, but it's more or less basically off like you're clicking with a controller, kind of like how you do with the PlayStation or Xbox controller. Nreal is basically another really, really great headset. I tell you from personal experience, it's basically the size of my glasses here. They're actually a startup based in China that's developing lighter, more wearable headsets. Project North Star is another augmented reality headset. Basically, they're using a leap motion depth sensing camera to project the images, and along with virtual hands. So it's actually using leap motion gesture interaction with the whole holographic environment. And then the headsets here all the way to the right, these are all VR headsets. So I'm sure we're all familiar with Oculus. Oculus, of course, is like very well-known headsets. I'm sure some of us have tried these on before. So Oculus Rift and Oculus Quest. Oculus Rift is more PC-oriented VR, while Quest is more mobile-oriented. Google Cardboard VR. So Google Cardboard actually, in my opinion, isn't actually real VR, because mobile VR still needs more work. But basically, it's just if you have a mobile phone and a Google Cardboard headset, which is literally just 99 cents for a Google Cardboard, you just put your mobile phone into the cardboard and you'll experience mobile VR. Like I said, interaction and immersiveness needs more work for mobile VR, which I'm sure Google can figure out. HTC Vive and Windows Mixed Reality headsets. So those are more similar to Oculus. I think HTC Vive is probably more ahead when it comes to the more interactive hand tracking and some of the physics collision built in. Windows Mixed Reality headset, I would say, they depend more on controllers, but the immersiveness is still there. Also, the hand tracking is really cool when it comes to Windows Mixed Reality. Basically, that's just using a Microsoft operating system, but I think Hewlett-Packard or HP, they're basically the ones that actually designed the hardware for the headset. All right, next slide. All right, so now I'm going to be talking more about mobile AR here. So the thing about mobile AR is, I know many of us cannot afford AR headsets like a HoloLens or a Magic Leap, over $3,000. Too expensive for most of us, especially if you're students, most of us are broke, don't have the type of money, but mobile AR, good thing about it is, well, if you already have a cell phone, well, mobile AR is affordable. It's very usable because all you need is a mobile phone and just some good augmented reality coding software like Unity. You are going to need the latest mobile phone. So whether some of you are Android or iPhone users, make sure you have the latest Android or iPhones. It is going to rely on a powerful depth sensing camera or a LiDAR sensor, depending on if you have Android or iPhone. SDKUs, if you guys are Android users, if you want to develop for Android augmented reality apps, SDK you will most likely use is AR Core. For those of us that are iPhone users, you will be using AR Kit. And I'll be honest, AR Kit developed by Apple is way ahead of us in this game. They're ahead of us in augmented reality as they have so many amazing features like body tracking built in for iPhone users. So here I'll show you a little sample video of an example of AR Kit. So as you see, there's 2D tracking going on. It's tracking the person's pose estimation. So 2D still has a little lag and not so much efficiencies. All right, so this is now 3D tracking. It's tracking the person's joint, angles. Its 3D tracking is a lot more accurate. It's overlaying onto the person. So this is all through iPhone or even through iPad. All right, and then this is just human segmentation, detecting a person's movement and pose.
Yeah, this looks amazing, actually.
Oh yeah, so if you have the latest iPad or iPhone, some of you guys have a big advantage. You can start this stuff literally right now if you want. All right, so now mobile VR. So I think I mentioned that a little bit before when I was talking about types of headsets. So mobile VR, well, it is affordable. I'm like Oculus, HTC Vive, Windows mixed reality headsets. They're not expensive as some of those augmented reality headsets, but they're still in the few $100s range. Mobile VR, as mentioned, it's a lot more affordable. You just need a Google Cardboard box. The problem is it's still not mature, not immersive, not interactive enough. But, if you do want to experience like a little bit of like somewhat feeling of realism in VR, really, you just need a phone and a Google Cardboard box. And most of the applications, mobile VR, I personally think is good for. Could be wrong, but I look at it as more good for playing games on your mobile phone. So if you're lazy and you want to be in a world playing games, mobile VR is definitely a way to go for that. All right, so now I'm going to talk a lot more in detail about applications. So I'm going to go each into every detail, starting with games, education, defense, and aerospace. Personally, my main favorite ones are robotics, medicine, brain-computer interfaces, and defense. Personally, there's a lot of big impact and a lot of overlapping applications in these areas. All right, so games. Gaming industries, they've been adapting a use for VR ever since VR has been huge to the market. Sony PlayStation VR has been developing their own headsets and have a couple of their own games. If you're right, some of you that watch Iron Man and played, I don't know if some of us played the older games of Iron Man. Well, if you want to really, really be Iron Man, there's Iron Man VR now. So that's one way to look at it. Valve, it's another great gaming industry based in Seattle. They're making their own VR headsets and VR games as well. Other companies are also adapting to VR technologies and using VR SDKs to make their own games. So Phantom Covert Ops is another popular first-person shooter game. Basically, VR for games, you're basically in a world as you feel you're actually in the game, and you can be any type of character depending on the game and situation you really want, whether it's in car racing VR, first-person shooter, superhero VR, and really more. All right, so here are a couple of VR games I have to really, really excite you and expose you. I'll start with the one to the left. I actually made my own Iron Man version VR. This was actually for a class. This is actually a very sample version. A lot of the application also uses biometrics for heart rate. Alright, so basically I'm able to shoot down enemies, fire repulsors, and basically fly around a simulation as if I was actually Iron Man. Alright, and I'll show a little sample of another game I made in VR, which is first-person shooter. It might be a little long, so I'll just kind of go to the points about it. Basically, I'm able to move my head in the environment, look around, and shoot down targets. Some of us who are a big fan of Halo or Call of Duty, imagine it in VR.
Yeah, so these all are made in Unity, I guess.
Correct. This is all Unity. Very, very good realistic graphics. So yeah, it's basically I'm able to explore the whole environment, basically shoot down targets. Skip it a little bit. Basically, imagine me playing this in VR. You're able to basically explore the whole environment. Basically, you yourself move around, shoot down targets. So yeah, I mean, I'll stop showing the rest of it. Sumit, do you want me to go or continue? I'm okay with anything.
Yeah, this was exciting. You can go on, I think.
Oh, like continue playing the video or go to the next slide?
Yeah, actually, it's very exciting. So this is like you're playing in Unity Studio, but this can be played in VR consoles as well.
Yes, actually, so that's the goal. So if you have Oculus Rift headsets or any VR headset, you just need some like VR SDKs or libraries, and pretty much it's just like playing any other game except in a headset.
Oh yeah,
it's pretty much
kind of a cool thing. So I guess students can develop it with like learning some programming, learning about plugins. I think student will be able to develop all these features in the game.
Yes, it's pretty much, it's more or less a modification. VR is basically just an additional tool to help you. So imagine this in basically first-person shooter. Yeah, for some of us, those are big gamers. Definitely go crazy with games like this. I myself, I'm a big gamer. Always a big fan of Halo or Call of Duty. Yeah, so Sumit, should I just go to the next slide?
Yeah, you can. You can switch to next slide.
All right. Education. So VR education. This is actually super important because VR is already being used for education for many applications. Like first is recreating virtual classrooms. So example is COVID. All of us can't unfortunately be physically in person due to the pandemic, and we would really like to interact. So VR, imagine recreating a classroom where you're with all your classmates, but in VR. Of course, the interaction wouldn't be the same as you would be physically together in person, but you know, in VR, you'd be able to feel like you guys are all actually here together in a virtual classroom setting, you know, virtual interaction in classes. So VR, basically, you're recreating a whole 3D environment of a virtual classroom as if you guys were actually learning in that environment together. So, and due to situations like COVID, unfortunately. Another thing is it's gamifying education. So let's say you're a person who really does not enjoy a particular subject. It's just like you don't like to read books, you don't like to study for exam, you don't like that traditional way of studying. It's too much pressure. Well, Why not gamify that pressure to make it more fun and interactive? Let's say you don't enjoy history class. Well, why not turn into interactive storytelling through a game, or make it in a virtual world where you can actually be in that storytelling environment and be able to experience the history of whatever you're interested in. It could be about your country or it could be about anything. So imagine putting on a VR headset and learning about the history of, let's say, the American Civil War. Why not relive it through a VR gamified environment to learn and understand, okay, this is what happened. It's basically, when it's gamifying education, it's basically making the subject more fun, it's making it more entertaining, and the student is getting knowledge out of it. So it's basically being productive at the same time, increasing their awareness and knowledge, making learning a lot more fun and less like an exam. Other places that are actually starting to adapt VR for educational use are medical schools to train the future doctors on the job. Because think about it, a lot of medical schools is good test-taking skills and studying ability. And it's important to have those test-taking skills, but I think it's also more important to gamify and give them real-world hands-on experience. So VR could be good for that, for, let's say, people that want to be surgeons. Of course, surgery is very important. It's very risky. And a lot of surgeons are very overworked people, and their jobs are very stressful. So why not put them in a VR environment that, they'll be able to make all the mistakes they are going to make as if they were on the real job? Because if you do it in VR, the less chance they'll probably make mistakes in a real world environment, because they'll be learning from these mistakes consistently. So VR, in fact, is going to be training the next generation of surgeons through medical education, and also other doctors who are probably going to focus more on the diagnostic side, like through internal medicine. So while diagnostics is important, you also need to understand the physiological side and how things work in the human body. So VR can really be an interactive environment in helping the medical students understand about more physiology in a very interactive way. So I think this is important for medical school, because it'll make them apply all these skills from the books and actually go more outside the box in a more innovative, immersive, and exciting environment. And this is where both virtual and augmented reality can play a role in different ways, whether it's virtual interactions or holographic interactions. I personally think it's going to really advance medical education and make the next generation of doctors be the best doctors. All right, so aerospace and defense. So military applications involve combat training and flight simulator training for piloting a jet. So let's say for combat training, well, it's important to train soldiers how to fight for war, right? There's so many situations in war. You never know if enemies have a plan against you first before you have a plan of attack against them. So through combat training in VR, we're able to put soldiers through all these different types of situations so that they're able to have better understanding of how to be better prepared when they're fighting in war. So they're going to have understanding, okay, if I go here and make this move, what if the enemy could shoot me first? So actually, what VR and combat training is doing for soldiers is preparing them more efficiently for real world situations when it comes to actually fighting in war. It's going to help prepare soldiers to be better prepared in fighting. Less soldiers will hopefully, get killed during the battle or captured or both. So I think that's really going to help soldiers prepare more on the battlefield and be prepared for anything the enemy is ready to strike against them. Flight simulators for piloting a jet. So let's say you're somebody in the Air Force, and before you pilot a real jet, you should have simulation training about how to pilot a jet as if you were doing it in real life. So you know how to pilot, where you're going. There could be a lot of situations. Let's say if your jet is about to get shot down or whatever, how to be better prepared for these situations. So virtual reality, in a way, is more simulation training, helping you to prepare for these situations more accurately. And I think, simulation training is also in the long run going to save more lives of, soldiers, because, these are young soldiers risking their life for their country. Cockpit systems. So actually, if you look at the future cockpit research picture I have here, this is the helmet development that the pilot is wearing. And through here, if you can see under future violet viewport, this is actually the whole virtual holographic images projected through like the helmet display that the pilot is projecting as they're flying the whole cockpit system. So actually, some of this project is actually very, very cutting edge and groundbreaking Department of Defense, because when the pilots are piloting the next future cockpit systems for aircraft, they need to be able to really have ideas about, navigation, where they're flying the jet, longitude, magnitude. Other applications could also involve, targeting systems, so like a red dot sign of knowing where you're actually going to fire, lock-on systems, other objects around your environment as you're flying. So a lot of this, at the same time you're flying a cockpit system, a lot of this data is being visually projected through a helmet display. So basically, it's helping the pilot have better awareness of what they're flying through. And I can also speak through this personal experience, as I'm also doing a project for National Security Innovation Network on the next future generation of cockpit using virtual simulations. Can't speak too much in detail about the project, but I think gave you some generic ideas. And really, there's so much more cutting edge applications going on. Another thing that virtual augmented reality is being helpful for is for space application use. So I'm sure a lot of us are familiar with NASA. So NASA is basically using virtual augmented reality for simulation training to train astronauts as they were going on to outer space to be able to understand tasks they were to collect. It's also being used for space navigation exploration. So space navigation exploration could involve navigating terrestrial environments on the moon. So actually, NASA, I can tell you the personal experience, because I've been doing a NASA project this year, which involves space navigation to the moon using a HoloLens 2 display. So NASA and SpaceX actually are working together using augmented reality technology and heads-up display to help astronauts go on the mission to the moon, understand more about the terrestrial environment and body structure of the moon, because eventually, as they master lunar exploration, by 2030, I'm sure we're all familiar with the mission to Mars. So basically, using the same procedure, augmented reality for space navigation, NASA eventually wants to integrate this for guided tours to mission to Mars to help, basically by 2030, send actual astronauts up to Mars and eventually start actual life on Mars. All right, so I'll show you a couple of videos of how NASA is actually integrating augmented reality. To the left will be what NASA has done, and to the right will be a sample video of my project. So we'll go. So this is augmented reality for destination to Mars use.
To the challenges we're facing in space exploration. Through a collaboration with Microsoft, we're building applications to support engineers responsible for the design and assembly of spacecraft, astronauts working on the International Space Station, and scientists are now using our Mars tool on-site in mission operations.
On-site's a powerful tool for our scientists and engineers to explore Mars. But because we always felt it shouldn't remain only within NASA, we've taken the core of on-site and made an amazing experience that allows the public to explore the red planet. We call this new experience Destination Mars.
Mars can be a lonely place. So we've created holographic captures of an astronaut and a member of the Curiosity rover team to be our guides on this journey. And this gave us an opportunity to immortalize a hero.
Hi there, I'm Buzz Aldrin.
To help Buzz explain how we're doing science on Mars today is Curiosity rover driver Arissa Hines.
Welcome to my office.
We can put the public, the rover and Arissa together at the exact place where Curiosity made some of its most amazing discoveries.
We're looking forward to opening the Destination Mars exhibit at the Kennedy Space Center Visitor Complex in summer 2016. We can't wait to share this journey with the world.
Let's go to Mars.
All right, now sample array. I'll show a quick video of my first demo I did for NASA for augmented reality displays for space exploration.